Hey guys, and welcome back to Up to Speed with Elasticsearch. We are up to Chapter 8, where we're going to look at index lifecycle management and data streams. Before we actually get into these two topics, though, I wanted to cover a little bit of background that hopefully will make these features a bit more understandable. So there are basically three high-level points that I want to cover before we actually look into the practice. The first point, which sounds obvious when you say it out loud, but the first point is not all data is the same. So what I mean by that is, as far as Elasticsearch is concerned, you can kind of categorize your data into one of two types. It's either content or time series. Now, you may argue there are more types than that, but for the sake of the video and for the sake of the feature, I'm going to focus on these two types. So if I were to say that your data fits in the content category, what I mean to is it's read and written to roughly equally. Data can be updated at any time, and older documents are still as relevant as newer documents. So some examples of these are product catalog, a blog, or a CMS. So just to imagine, say for example, a typical CRUD application. Maybe it's some kind of a catalog where administrators can manage like products that are for sale. So there would be screens where data would be read. It would show lists of different categories of products, and you'd be able to open up different product details, and you'd also be able to create new products and modify existing products and things like that. And you'd say that there's roughly a 50-50 distribution between reading and writing. On the second point, data can be updated at any time. If you can imagine there was a product that was created last year, some administrator could always, at any point, go back in time or open up that product rather and make changes to it and save it and update it. So there's no real limit as to how old a document can be or how old a product can be, where it can no longer be updated. And I suppose similarly, older documents are still as relevant as newer documents. If you're looking for a specific product, it doesn't matter if that product was added to the data set a year ago or 2 years ago, it still should show up in search results. The age of the document doesn't really contribute to its relevance. So that's kind of content. Imagine typical CRUD application. The other type of data is time series data. So time series data tends to be write heavy, written to more than it's read, tends to be immutable once a record is written. It's very rarely, if ever, actually updated. And recent documents are accessed far more often than older documents. So a couple of examples, think of application logs, readings from sensors or IoT devices, application events. When we talk about events here, we're talking about things like a login event, a record got created event, and things like that. So maybe let's focus on application logs. Imagine a logging platform like New Relic, Sumo Logic, Papertrail, etc. One of those online logging solutions, CloudWatch, and so on. Think about how often you would actually read your application logs compared to how often they're actually written. You'd really only read logs when something's going wrong, but your applications are writing logs all the time. So they definitely would satisfy that point of being write heavy. When would application logs actually get updated? Probably never. Once they're actually written and ingested into the logging platform, they probably would never actually get updated. So yes, check, they would be mostly immutable. And recent documents are accessed far more often than older documents. So if you jump into an online logging platform, you're probably only interested in logs from the last day, couple of days, maybe a week. It'd be very rare to look at logs that are older than a month unless you have a very specific reason to do so. So you can kind of see there's two types of data here. And index lifecycle management and data streams are nice features when applied to time series data, more so than content data. So that's kind of what's going to be the focus of the video. So that's point one. Not all data is the same, and for the sake of the video, we're mainly going to be focusing on this sort of time series data. The second main point in relation to those features, lifecycle management and data streams, is not all nodes have the same specs. So you can imagine a cluster might look something like this, where one node is really powerful. It has a lot of storage, a lot of memory, a lot of CPU. You've got other nodes that are kind of not large at all, and some nodes in between. So you have some variation between the specs of nodes that are on your cluster. And lastly, not all nodes do the same thing. So if there's variations in your data and there's variations in the performance of your nodes, it kind of makes sense for certain nodes to do certain things. So Elastic has this concept of node roles, and depending on the role of a node, it's going to be performing different types of tasks. So if your node is a master node, it's basically going to be orchestrating the cluster, making sure that all of the other nodes are doing the right thing, and so on. If a node is a data node, then it's going to be responsible for CRUD operations, searching, aggregations, and so on. But diving deeper into the different types of data roles that are available and the different types of nodes you can have in your cluster, so to speak, there are these more specific data roles. So as mentioned, if your data is definitely more leaning towards the content category, you might give it the data content role where it will be optimized for that particular type of data. But if your data is more time series data, you might choose to give it one of these three nodes, one of these three node roles. So hot data is probably going to be assigned to a powerful node, where this is going to be the fresh, recent data that's going to be queried more. It's going to be written to more. Therefore, it needs the more powerful node to handle that work. Warm is for sort of semi-recent stuff. Imagine, perhaps week-old application logs or a couple days old application logs might still get read, won't be written to anymore, and certainly won't be searched as much as the hot data. And cold, you can imagine as old data. It's probably not going to be read often, if at all, and it's certainly not going to be written to. So maybe a less powerful node could be assigned this role. And you have another role for ingest. If you have complicated ingest pipelines, which we covered in the last video, you can assign the ingest role to a certain node if you want to have a node that's dedicated for running ingest pipelines. And there are other types of node roles as well. But for the sake of the video, we're mainly going to focus on these three: hot, warm, and cold, since, as you can imagine, they apply very nicely to time series data, where hot is for recent stuff, warm is for semi-recent, cold not so recent. So that's all the background that I wanted to cover, ish. Getting into the actual features themselves, index lifecycle management. This allows you to modify your indexes, so to speak, for when your data access needs change over time. So what I mean by that is, let's say you have a rule where any data that's 14 days old or more can be frozen. In other words, you can lock the index so that it becomes read-only. You can't write any new records to it after 14 days. Index lifecycle management can allow you to do that. You can create a policy that applies that particular rule to your index. You might have another rule that says, okay, any data that's older than 30 days is read less frequently than newer data. Therefore, maybe we can move it to the warm tier instead of the hot tier, so we can store it on less expensive hardware, and we can use this expensive, powerful node just for more recent stuff. And you might say, okay, well, maybe data that's older than 90 days can be deleted altogether. We don't need to store it any longer. Again, index lifecycle management policies can help you do that. You can also roll over data to a different index after it reaches a certain size or a certain age. So you might say, okay, I've got this index that lives on my hot node, and after the index reaches, say, several gigabytes in size, for example, or hits a certain number of documents, be it 1,000 documents, 10,000 documents, or whatever, or the age of the documents exceeds a certain size, I'd actually like to roll over that information to a second index, and that second index might live on a warm node, for example. So ILM policies, index lifecycle management policies, can do all of that stuff and more. What about data streams though? So we mentioned earlier there is this feature where you can roll data over to a second index. But what about if you still wanted to be able to read from that index? If you've rolled over your data 10 times to 10 different indexes, does that mean that you need to explicitly query 10 different indexes? Well, without data streams, maybe. You could probably get around it by using an alias, but data streams make it much more automatic and much more seamless for you. You can just write to the data stream, the data will roll over, you can read from the data stream, and you don't really have to worry about the fact that data has rolled over to a second or third index at all. You can just query from the data stream. So that's quite nice. So that's pretty much what the features do. Let's get into the tasks and actually try it out. So we have 4 tasks here. I'm going to copy these into the Combiner console and we can get started. Okay, so perhaps before we actually get into ILM policies or data streams, let's just look at the roles that the node on our cluster has. Since we mentioned earlier, node roles are really important and really relevant to ILM policies and data streams. Well, we have a single node cluster. Which roles does our node have? The way that you can retrieve this is by performing a get to cat nodes, and let's use the $v query parameter. And this is giving us a single node. We've got some other metrics here, but the main stuff that we're after is this node role business. And really, it's just giving us a bunch of letters. So to make much sense of this, you might need to look at the documentation for the cat nodes API. And if you scroll down, we can see kind of a legend. So M indicates master. Sorry, is that right? No, here we go. C indicates cold, D indicates data, F indicates frozen, and so on and so on. So you can use this to figure out what roles a certain node has. So looking at us, we have cold, we have data, we have hot, we have ingest. Looks like pretty much everything, which maybe is not surprising because it's only one node on the cluster. All right, so second task is to create an ILM policy which applies a warm phase after 30 days and rolls over data to a new backing index also after 30 days. And data should be deleted after 90. So I'm going to run a post to ILM policy. Is that right? Let me quickly check the documentation. There we go. So I need to give it a name, and it's going to be a put instead of a post. I'm going to call this perhaps logs, since let's just imagine this is for some kind of a logging application. And there we go. So a policy is going to have phases. It's going to have a hot phase. The minimum age probably doesn't, well, let's see. We don't really care about setting the priority. We don't really care about setting the min age for the hot phase. We do want it to roll over after 30 days, and we don't care about the maximum number of documents or the maximum size. So this should get data in the hot phase to roll over after it's 30 days old. The next thing that we want is we want to move it to the warm phase also after 30 days. So the next phase will be warm, and the min age will be 30 days. And we do need to provide an actions object, but I'm just going to leave this empty since we don't really want to actually do anything. We just want that rolled over index to be assigned to a node which has the warm role. And lastly, we want to delete data after 90 days. So there's going to be one more phase which is going to be delete, and the min age is going to be 90 days, and it's just going to have a delete action. So let's go ahead and run this. Looks good. We can retrieve it just to make sure it got saved. ILM policy logs. Okay, so we've got our phases. Warm phase set to 30 days. Hot phase set with no minimum age, so it's immediately going to be hot. It's going to roll over after 30 days, and it's going to be deleted after 90 days. Sounds good? Next task is to create an index template to apply the ILM policy. So the way that we kind of associate the policy with the data stream is with an index template, which we looked at, I want to say 2 videos ago. If you forgot how they work, feel free to refer back to the previous video. I'm going to refer to the documentation. We've got the policy. Scrolling down a little. Okay, we want to create, we want to issue a put to index template and specify the name of the template. The main thing to watch out for here is the data stream property and this setting, which basically says any index that gets created which matches this pattern is going to have this lifecycle set, and that's the name of the ILM policy we created in the previous step. So I might just copy paste this just so I don't mistype it. And okay, so the name of the template is, let's just call this logs-template maybe. The index pattern is, let's just go with logs. And it's going to be a data stream. We can leave the priority. The lifecycle name is going to be logs. So that matches the ILM policy name that we created earlier. If we go ahead and run this, looks good. Let's retrieve it. Nice, so we've got an index pattern. There is this index setting here. It's not composed of any component templates, and it is a data stream. So to actually create the data stream, all we really need to do is to issue a post to create a new document. The main thing to keep in mind here is that because it's time series data, it needs to have a timestamp. So again, I may just copy this over. So our data stream is named, what do we name it? Logs. Sounds good. Our timestamp, we might set this to today. So it's 2023 11 the 10th. I might leave the timestamp as it is. I don't really need this user ID, but I will leave the message there. All right, let's go ahead and run it. Looks good. And let's actually have a look at our indexes. So we can see we've got this interesting index here, which is in yellow health, called ds-logs-blah, blah, 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 blah. And this period means that it's an index that got created by ElasticSearch as opposed to being created by us. This ds prefix means that it's a data stream, and this logs basically is the name of the data stream that we created earlier. Yeah, this data stream is what's in between the ds and the number at the end. Interesting question for you guys is, why is it in yellow health? If you'd like to pause the video here and just have a think about it, feel free to do so. But the hint there is it's to do with the settings. Remember the settings that we've applied to all of the indexes previously in the course, where we've set 1 primary shard and 0 replica shards? It looks like we've forgotten to do this in the case of the data stream, and that's why it's showing up in yellow health. So in practice, of course, we would need to apply those settings as appropriate. In terms of actually reading from this, we can just do a get logs search. If you wanted to apply a query, you certainly can, but I'm basically just searching this as if it was a regular index, and run a search. We can see we've got one document, which is the document that we created earlier. Here is the hit. and here it's telling you the name of the backing index. So even though we're running our search against the logs data stream name, it's actually searching this backing index. And if we were to wait for 30 days, because that's our rollover configuration, our data should get rolled over to ds-logs-00002, but we'd still be able to search it just using the name of the data stream. So that's pretty much index lifecycle management policies and data streams in a nutshell. If you have any questions, feel free to drop them in the comments. Otherwise, I'll see you, or I suppose either way, I'll see you in the next video where we talk about backups. Thanks a lot. See you later. Bye.